back. This one's called Catching Car Mileage Numbers. 7778, exclaimed Bob. I missed it again. Arr. Every time there's an interesting number coming up, he notices and then promptly forgets. Who doesn't like catching those one-off interesting mileage numbers? Let's make it so Bob never misses another interesting number. We've hacked into his car's computer, and we have a box hooked up that reads mileage numbers. We've got a box glued to his dash that lights up yellow or green depending on whether it receives a 1 or 2 respectively. It's up to you, intrepid warrior, to glue the parts together. Write the function that parses the mileage number input and returns a 2 if the number is interesting, a 1 if an interesting number occurs within the next 2 miles, or a 0 if the number is not interesting at all. We're not in Haskell, so we'll avoid that note. So we're going to define the interesting numbers here. They are 3 or more digit numbers that meet 1 or more of the following criteria. Any digit followed by all zeros, like 100 or 90,000. Every digit is the same number. Consider this all ones. The digits are sequential, either incrementing or decrementing. 1, 2, 3, 4, 4, 3, 2, 1. And if you check the notes, it just basically says that zeros can't be in the middle. You know, you wouldn't have 7, 8, 9. Or in this case, it's okay because the zero's at the end, right? And same here. But if the number were 7, 8, 9, 0, 1, 2, that would be invalid. So the zeros basically has to come at the end. And we're checking for palindromes. 1, 2, 2, 1 is the same if you print it in reverse. Same for 73,837. Notice reading from the front or back, they read the same. And then the digits match one of the values in the awesome phrases array. So we get this list that can be passed in as well. It may be empty, but it has other values to look for, and it could be anything. So you should expect these inputs and outputs. 3, we saw that the number had to be at least 100 to even be interesting, so it's not surprising that that's a 0. 32, 36, clearly not in the list or anything special above, like a digit with all zeros or the same digit. Let's look below. Go through all these if you want. I'll try and point out the more important ones. Notice this 11209 is returning a 1, which is almost interesting. And that's because if you add 2 to it, which was our threshold, remember within 2 miles they said, you get 11211, which would be a palindrome, right? You can see it here. You can see it stepping up 1 mile, and then finally that 2 clicks in because it's a palindrome. But here it's close. It's within 2 miles here, within 1 mile there, so those are both interesting. Almost interesting. And then notice how these are getting close to this first awesome phrase that is passed in. 2 miles away, 1 mile away, and then you hit it, so it's marked as very interesting. Error checking. A number is only interesting if it is greater than 99. Input will always be an integer greater than 0 and less than 1 billion. And the awesome phrases array will always be provided and will always be an array but may be empty. I think it's a list. Yeah, it's a list, not an array. Not everyone thinks numbers spell funny words. You should only ever output 0, 1, or 2. So if you're kind of thinking about this, it's definitely more involved than anything we've done here. There's kind of a lot of moving parts. This is almost like 5 of the normal problems we do kind of combined into one. And so because of that reason, I went ahead and sort of sketched a design first that I'll share with you. If you don't even want to see that, you can do your pause now and just go after this one. If you'd like to see the design first, you can do that to try and get some ideas and then go after it. I'll leave that up to you. Pause the video at whatever point you think is appropriate. So to start, I drew up something that's like UML very loosely. It's not UML. You can check out UML if you'd like to see more about that. It's a way to sort of document your code and your class design. You can think of these boxes as representing classes that I'll make, or in this case, it's an enumeration, but this is the idea. The arrows are sort of meant to symbolize inheritance, which means this will be a base class, and these ones will inherit from it. So we are going to get into inheritance. Here we'll talk about that. That'll be a good introduction to that. And so I'll sort of get into what the design actually is. The enum is simple enough. I just made those 0, 1, 2 values that they expect, and I named them none, almost, and full interest. And so the class that they gave us stubbed out is this kata. You know, they had that method is interesting that we have to implement. And so I made my general strategy here. I'll start from here and sort of break it down. I'm going to have this helper method that just validates the input. We're going to make sure that num or number is greater than 0 and it's less than a billion, or whatever they told us the max input should be. And then finally I made this interest catalog class that's going to basically serve kata and keep things really simple. So I'll make an instance of that object, and it has this method called getInterest, and then kata can simply just return whatever value it gets from this method. And so we'll step one layer down in the design. You come to this interest catalog. So you can see here, right? I just kind of deferred all the work off to this. I did one little thing. I did input validation, and then I sort of offloaded all the heavy lifting off to interest catalog. And it's going to do a little more and offload the work to someone else, and it creates this nice, these stages, or like these layers of an onion, or however you want to think of it, where you're introducing a little bit more detail at each time, and that works well for design purposes. So here I sort of introduced that constant that's going to be the minimum required value for interest. Remember, they said anything under 100 is automatically not interesting, so that's useful. And then I'm going to have this collection of something called interest calculator, which we'll get to. Just let it be for the moment. But we're going to have all of these, and the idea is that we've got all these different flavors of it for the different kinds of interesting numbers we have. We had one with digits with all zeros. We had ones with where all the digits are the same. We had sequential, ascending, and descending. We had a palindrome, and we had awesome phrases. So imagine I have an object dedicated to each one of those ways of determining interest. And that's really handy. Then I can just load up this list with them, and then when kata calls getInterest on me, I can iterate over this collection I've made. I do this at construction, so it's going to create an interest catalog object, and at that time I'm going through and making all of these different types of objects and storing them, and then I'm ready. Anytime someone calls my getInterest method, I already have these all populated, and I call each of their getInterest methods. And so I can sort of aggregate those results and return something as appropriate. You imagine if I get even one full interest result, the whole result's full interest, right? It's okay if none of the others match. If even one matches, it's considered an interesting value. Then if no fulls are returned and I get any almost values, even one, same kind of thing, that's going to trump, and it's going to take over as the result of the entire function. And then finally, if there's just no interest reported anywhere, I'm just going to say interest none. So that's a nice step down, right? We have these handy things. We don't really need to know how the interest calculator works, right? We just know that we have these objects. They have this method called getInterest, which is what we want. And then we can sort of just gather all those values and then determine the right way to return based on all of those. And we'll get into how we do that with the implementation in the code. I mean, we'll use some kind of bit masking to set flags for each of these interest values and sort of favor them from the bottom. If there's any full, return full, like I said, that sort of thing. So then let's step down another level here and we come to this interest calculator, and this is going to serve as what is called the base class that all these other classes derive from. So the idea with the base class is that it takes care of the functionality that's common to all of these types. You can imagine that there's something that all of these will have in common, and it's going to be implemented here. And why we do that then is that I don't have to repeat the implementation in each one of these classes. Imagine if I just made these all as separate classes, how much code they would have in common and how wasteful that would be and how annoying that would be to type out the same code, even if I'm copying and pasting it. That'd be very annoying. And then it's tough from a maintenance standpoint too, right? If you have all this copied code and then you decide you want to change something about it or find a bug in it, then you have to go fix it in every place that you copied it. And that's an absolute disaster. You don't want to do that. So let's try and understand the interest calculator base class first. Note that I stored this, what I call almost proximity. They said within 2 miles is sort of what qualifies as being almost interesting. That's why I named it that way. The 2 would represent 2 miles. Then I have these name and contribution fields. This is just they were made to help me sort of debug the program as I was writing it. I could see what value each one of the subclasses was returning, and I was able to print it by using their name and their contributions. So that was really handy. But I don't think any of this was necessary to actually getting the challenge done. But it came in handy. You can remove it or not worry about it. This is the input number that came all the way from Kata get interest. Remember, they pass in a number, and so I just sort of cache it here. It just stores whatever value was passed in. And then with my constructor, I require a string name, which is going to populate this name field. And then it also takes a list of extra target values. And this was to accommodate that awesome phrases thing. And so any extra targets kind of come in here, and I can put them right into my targets collection here. And then imagine each class is going to generate its own specific target according to its rules. But you could give it extra targets if you wanted. Mostly, I won't use extra targets with any of these, but if you notice, I didn't make an awesome phrases derived class, and that's because it's actually covered by interest calculator. This will serve as the awesome phrases class. I'll pass those extra targets in here, and then it will have its target values. These other classes are going to have to add their own, and they'll just have 1 target value, or maybe 2 in the case of the sequential, since I'm going ascending and descending. So there, yeah, at that time we call the constructor. That's good. We have this get interest method, which is again what was invoked by Kata. It's what was called on each of the interest calculator objects we have, and so we'll talk about how that works. I basically have this virtual method, and to talk about inheritance, you'll encounter virtual methods. That's kind of the point where you can override behavior in your subclasses. You can make it do something different based on its specific type, which is really handy. And I can just, from here, I can just say add main target, and then magically each of these have their own implementation, and it just does the right thing for me. So that's really nice. In this base class then, I can just say add main target. I can call this method, and then depending on what type of interest calculator it is, it'll create the appropriate target. And that's really handy. And then once I do that, the idea is to search through all of the target values and check for a match with that number that was passed in for get interest. We know if it matches exactly, that denotes full interest. If it's 2 miles or less away from the target, that's almost, and then finally you just return none. So yeah, this is where the magic happens. I made it protected. We haven't talked a lot about the protected keyword. It's in the same category as public and private as an access modifier. Protected is used Imagine it's something between public and private where derived classes can access it, but outside classes that are not derived could not. So a class like interest catalog, it would effectively be private to that. And if it's a class like one of these derived ones, it's like public to them. So that's how that works. And then, yeah, so we get down here, in these classes, there's really not much to do. They have all of the same, this is important to know, that they have all the same fields and methods as the base class. So I didn't reprint them out up here. I mean, I should say they have access to these. You know what I mean? It's not like it's duplicated. It's not making a second name field in all of these classes. But you can access it, right? It's a public or even protected would have worked here. So, yeah, in the case of a digit with zeros, to add main target, you're going to want to basically look at the number's first digit, add a bunch of zeros that are appropriate for its length, account for that +2 if necessary, and then add your target. You know what I mean? It gets stored in this collection of targets. You'll add it there. And the same kind of idea with these other ones. We talked about what same digit, sequential, and palindromes are. And so yeah, that's the design in a nutshell. Obviously there's 1,000 ways to think about this. This is what I came up with when I thought about the problem at the time. You know, it doesn't mean that it's the only way. You could have come up with something different and that's much better. You know, there's no right or wrong way. There are ways to make mistakes, there are ways to do extra work, but aim for simplicity. That's what I was going for. Try not to type a bunch of code over and over again. I had noticed when I was doing these things that there was a lot of behavior in common, so it's like, yeah, let's factor that into a base class where I can just keep reusing it, just tweak it a little bit in these derived classes to do what you need to do. So I'll go back to code and essentially put the code in for this design. Again, if you want to pause now and do yours, go for it. So I think I had the private, we had validate input, right, to start. So I should say private void validate input. And we were going to check, it takes in a number. That's what was getting validated here. There's no real validation for the awesome phrases. It could be empty, can have any value. They don't need to make sense. So if number is less than 0, or I think it was 1 billion they gave us, I'll say less than or equal to 0, or if number is greater than 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion, maybe we'll just throw an exception here, throw new argument exception. We'll put a helpful message there. Number is out of range. Okay. So I can take that and sort of first things first. You know what? We're leaving. Because you can imagine, right? If you had gone through and implemented all this, you didn't have any sort of validation, and then you get all these weird errors that come up. And you're thinking, man, what the heck did my code do wrong? And you waste all this time trying to figure it out, only to find out that you got some bogus input that should have never been accepted in the first place. And that's quite obnoxious when that happens. So add some protection for yourself there. And then, so okay, that's a good start. We got clean input after this, as clean as it can be. So then I said we had this, as the next stage, we had this interest catalog class, right? So let's go ahead and make a class for that. Public class interest catalog. Okay, for this, we're going to want that get interest method, right? I usually like to do the constructor first, so let's do that. Public, the same name as the class, they have to match. And then I said we were going to take that list of extra targets as a constructor because we need that for our awesome phrases calculator. So list of int awesome phrases. Okay. And then for our constructor, we essentially want to add each type that we made, each of those derived classes. So I can do that. I should probably make the field that stores those first. So let's make a private field for that. No one else needs to know about it. Private list of interest calculator. And I will call it just calcs for short. And we can just make a new list here. And I suppose I could start bringing in some of the classes that we're going to need for this. We know for list we need using system, collections, generic, right? I think for the exception stuff I need using system. So we have that. Now we can sort of build up this list in the constructor, and then it will be ready whenever we call the getInterest method. So I'll go ahead and add some of those. We know to add to a list. There's an add method. And then I haven't made the interest calculator class, but remember they took a name and a list of targets. So that'll sort of be the parameters that we'll add for creating these. First one, I'll say add new interest calculator. We'll create a new object, right? That's how we do that. And we can just call this one awesome phrase or whatever string helps you identify which calculator you're dealing with. And then I can pass it that awesome. You know what? I'm going to stay with the language that I used in the classes. That would be more appropriate. Extra targets, right? These are extra targets passed in by kata. And then I can pretty much duplicate this line. I think I have 5 of them in all. And we'll rename those. The other ones don't deal with extra targets. Remember, only awesome phrases does. That one's based entirely on the extra targets. The other ones generate their own targets, and there's nothing extra to have for a digit with all zeros, for example. So we'll just give these ones names. Let's call one sequential. It's pretty obvious. We can say same digits. Palindrome. And how about digit with zeros? Okay, so obviously this wouldn't compile yet. We haven't made interest calculator, but this is the idea, right? And that's sort of the nice part about designing up front, is that I could be doing this, you could be doing the other part, you know, and we meet in the middle in half the time. So good. The constructor gets called as soon as we create a new interest catalog. You know what I mean? When we did something like this, just catalog, I'll just call it catalog equals new interest catalog. And that's when the constructor gets invoked. We did say that it took awesome phrases as a parameter. So we'll put that in. Those are what we'll call our extra targets. Remember, we said that here, that the constructor has to have that. So I'll do that. That matches up. Good. Beyond the constructor, right, we're going to have that method that serves the kata class. That's sort of, I think I called it getInterest. Yeah, this one right here. So we're going to want that public int get interest. It's going to take a number. Okay. Public interest. You know what? I should make the enumeration. Remember this little guy here. Let's just go ahead and implement that. It doesn't need to be in a class. It'll be outside its own item there. So I could say public, because I'm going to have multiple classes referring to this. Even the coded class, I would have, if I were making this whole program myself, I would have had used the enum instead of switching to a number at the end, because I don't like the magic numbers. But and we've used enums before. You can give them specific values. Almost equals 1, full equals 2. And then I'm going to add an attribute called flags that will allow me to sort of do some bit mask manipulation with this. Do look up C# attributes if you have questions about those. I have a lot here going on to get into all this now, but basically I can sort of set, imagine these as, imagine columns where I could set 1. If I hit full, I could tick it. If I had an almost result, I could tick it, and they wouldn't necessarily overwrite each other. It's that kind of idea, and then I can check if full's ticked and return that, otherwise almost or none. So that's the idea there. Okay, we've got the enum, and then I want my method, this method here, to actually work with the enum. And I can convert and kata at the end, but I want to use my enum as much as possible. So we've got that. And then the main idea, right, is to go over our collection. Interest calculator, calc in calcs. We're going to go over all of these and check. And we'll sort of make this field to, oops. Interest. Well, the default value will be none. We'll just make it say none to start. And then we can tweak it as we find any kind of interesting results. And so we're going to modify this result with each result coming in from the calcs. So I can say calc, we know that's going to have a get interest method as well, right? And for this, I'm going to basically modify my interest value. I'm using the or equals. If you recall our lessons on the logical operators, to sort of combine results here without clearing. So I could have, imagine I encountered an almost interesting result. It would get sort of ticked here, set to 1, and then I came to a full interest result. It would set that field without just completely overwriting the variable and clearing out that other data. So that's the idea, is that I'm sort of combining all the results here. So we got that. And then finally we're going to make that logic that favors the full result. If that's present, that trumps everything, right? So because I added that flag attribute, I have this option where I can go has flags interest full. That means I found at least one result with full interest. And I can say return interest full. And I'm going to copy this, same kind of idea for almost. And then finally, if neither of those are found, we can say return interest none. I suppose interest would have already been none. I could have just returned that, so you can change that if you like. And then I'm going to add a couple shortcuts here. We can use the, I didn't add the field yet for the values less than 0, so let's go ahead and add that, or less than 100. So we'll say private static read only int, which I call it interesting min value. This is sort of that threshold, right? That was in the rules that they gave us. I'm going to copy that, and then before even firing off our logic here and going through the calcs, we don't even have to bother if we have a number like 3, right? So we can add some shortcut here. If number is less than interesting value, return interest none. And then imagine we had, I should say, because 99 wouldn't be. We know 100 is an interesting value because it's a single 1 followed by zeros. So that would be interesting. So I should say minus 2, which is that almost proximity field I didn't make yet. We'll get there. Then it would be none. So below 98, right? That would be none. And then same kind of thing. At this point, if it's less than 100, we're going to say almost. This would cover the case of 98 and 99, and those are within 2, so we'd say almost. And that gives us a little optimization where if we can immediately make a conclusion, then we do. So that's most of the interest catalog class. I guess we'll get into interest calculator then. We'll go ahead and implement that. Public class. Let's expand this, give ourselves a little more real estate. This is definitely taking up more space than we're used to, right? So public class interest calculator. Okay, this is our base class, right? So we're going to do the common functionality here. I like to start with the constructors. I think we said we were going to take a string name and that list int of extra targets, and this is going to be optional since it only applies to the one subclass dealing with awesome phrases. So remember, like when we did this with methods, we called that a default parameter, right? You didn't have to provide it. You could use it if it is provided, but I'm just saying this thing could be null and not present, and that's okay. Don't need to throw an error over that. So we'll say if extra targets is not equal to null. Let's go ahead and make the field that I want to store the targets in as well. List int targets. I made this protected so the subclasses could access it and add their specific values to it. List int of targets equals new list of int, just to initialize that, just so it's not null. And so here, if it's not null, we'll say targets equals extra targets. And then for awesome phrases, this is all, it doesn't have to add any other targets. It just uses whatever's gets passed in here. And then else, there's nothing really to do else. So I suppose I could have initialized the list there, but I could have said else targets equals new list. Just do it like that. Okay, and then we also had this name field, right? So let's make a field called name and set it something like that. So I'm going to make mine public string name get private set. People can look at it, but they can't change it. That's why I did it that way. Okay, and this will be helpful for debugging. We can get the names of these, the subclasses, the objects derived from this. So we got our constructor done there. I'm going to add that public static read only int. We'll called it, I think, almost proximity. That defines that 2 mile proximity, if you will, of a target value. So that's good. Another field that I had made for debugging purposes, interest contribution. And I sort of store the results of the get interest call here, and that way after the fact I can go through and sort of query each calculator and say, hey, what's your name, what's your contribution, and it will say, hey, my name's Awesome Phrases, and I said there were no matches, there was no interest. You know what I mean? So this can be, you don't need it, but it's just really nice when you're getting errors, and you can find out who's analyzing which way, and then you can check it yourself and say, oh yeah, that looks right, or no, you should have said almost in this case. So that's the idea there. And then we do have to make this public interest get interest method that takes a number. Right? This is what we leverage. Each calculator can call this method. We can call it on all the calculators, and they all do their own specific magic. But here in the base class, we can take care of all the common behavior, not worry about the specifics, leave that up to the derived classes. So we have, I'm going to go ahead and add to my protected fields the input number. Get, again, you can look at it, there's no need to change it. And so when I call get interest, I'm going to first things first, sort of cache what that number was. And then the derived classes can work with it by accessing this field. I suppose similarly you could have, in the add main target method, you could have passed the number through that way. Maybe that makes more sense if you like that. You could do that. Then I'll call add main target. Remember, this is going to be where the specific magic happens. And then, so at this point, each derived class should have at least one target, perhaps many if you're dealing with awesome phrases. So I want to go over all of the targets. In targets, we call it the collection. And for that, we're going to check each one. If the number passed in is equal to a target, doesn't matter which one, if it matches exactly with any target, we have full interest, right? So I'm going to help my debugging here. Equals interest full. And we can just simply return at this point. Let's say we're at just looking at the first calculator and we already found full interest. We sort of short circuit. It's like we don't even need to, there's nothing else to look for, you know what I mean? We sort of have our answer because full trumps everything, so just return it. You're done. no sense in looking. Who cares if the other ones are almost or none, right? So then the next phase would be to check if an almost hit. So for this, I'm going to use an absolute value here. Say target minus num is less than or equal to that almost proximity. It's within 2. And I'm just going, at this point, I'm just going to make a note of it. I can't return, right, if I find an almost, because I never know if a calculator downstream is going to find full interest. So let's just set up a flag to make a note. Bool almost interesting found, default value to false. And then once we find one, we'll set this flag to true. True. Okay. So that we've gone through all the targets after this for each loop, assuming we make it beyond this. If we make it beyond this, we know that full interest wasn't found because it would have just returned already, right? So the only thing left to do is determine if we should return almost or none. And so we can check our flag if almost interesting found contribution is going to be equal to interest almost. Otherwise, it's going to be contribution equals interest none. And then we can simply return the contribution, whatever it is. And the contribution allowed us to log that value. So that should cover us for get interest. We have our input number and our targets. And then finally, I'm just going to make this protected method, right, where the magic happens. And I should make it virtual so that the derived classes can override it. That's the point of virtual. Tells classes downstream, derived classes, you do whatever's specific for your needs here. You don't have to just accept our default behavior. You can make it appropriate for your context. That's the idea with that. I called it add main target. And in this case, I'm just going to leave the method body empty. I'm not going to do anything. This implementation covers the awesome phrases calculator, and so there's no other targets to add in their case. It just uses from the constructor, remember those extra targets? It just assigned those targets. It doesn't have any more to add. And so you can imagine the other ones won't have extra targets, so their target list will be empty to start. And then when they call this add main target method, they'll add 1 or maybe 2 targets appropriate to their type. So we'll have to implement that method in all the downstream classes. I think that covers us for the interest calculator class. So not too big, was manageable. So we'll go on and make the derived classes from the chart. Let's start with public class. I'll call it sequential interest calc. And when I name derived classes, I try to keep the original class name at the end and then just put what's specific about it as sort of a prefix. Usually I copy it exactly, but sometimes the names get kind of long. So I'll just leave it like this. And then the way to invoke inheritance or to specify that relationship is with this colon. And then I can say interest calculator. So this isn't just a blank class, you know what I mean? This is sort of has all of the behavior of interest calculator, and then within this scope I can add anything that's specific to sequential. So let's do that. I'm going to have to add a constructor first. So that's got to match the class name, right? And for the constructors, for these ones, all I'm going to need is the name. I don't need the extra targets for sequential. It's just not relevant here. So one other new concept that's going to come up with inheritance is that I'm going to invoke the base class's constructor like this. So I'm making a constructor, right? I don't have anything specific to do in this constructor, so I'm going to leave it blank. But I am going to say invoke the base class's constructor. So whenever someone creates a sequential interest calculator, they're going to pass a name like we did. Remember that in the catalog? We passed the name sequential there, right? And then in the interest calculator class, you know, it's going to get this name only. I didn't pass extra targets, and it's okay because I allowed for it to be null. And so it'll go ahead and set the name field here. And that's, you know, that's part of this, right? I said it inherited from interest calculator. So it's going to set the name field with this statement. If I had some specific behaviors to do in this constructor, I could add them here, you know what I mean? I could put this on multiple lines and type whatever I have to do. I just don't have to do that in this case. There's no more work to do. But we do have to do the magic, right, of the main target. So the way to override the function, I'm going to keep the same access modifier. Remember, this could chain. You could have some derived class from sequential interest calc. Maybe you made specific ones for ascending and descending that are derived from this, you know? I didn't do it that way. I cover all that behavior here, but you can imagine how you can get chains of these. So something to keep in mind. Use the override keyword to say that you're overriding the original method. And we called it add main target. And this is okay because this is marked virtual, so I can override it and give our specific behavior. If I didn't override this method, it's going to do nothing, right? Because that's what happens in the base class. And that would be a disaster here because it would have no targets. We didn't pass in any extra targets, and it wouldn't add one here. And so this would essentially be worthless. So we don't want to do that. Now, we're going to add the main target. I had implemented the logic for these methods, and so I'll go ahead and paste them in. I'm worried this video will go very long if I sort of walk through creating them. And plus, like I had mentioned, a lot of these derived class implementations, they're pretty much like the challenges we've done in the past. You know, within that scope, they're about that size where you just kind of worry about one problem, one method that you implement. And so I'll just paste those in here. We'll go over them quick, but I won't write them from scratch. So for add main target, the strategy was basically convert the input number. Remember, we stored it. I had mentioned you could have passed it in this add main target method. Maybe that's better. That's fine if you want to do it that way. But anyways, I converted it to text. I made a method. I'll bring this get target method in too. That's the other part that's needed here. So I'll grab that. We'll put that in. But anyway, imagine the get target can return either an ascending or descending pattern. If true, it's going to give you ascending. If false, it's going to go the other way. It's going to give you the value, 1, 2, 3, 4, and if it was going the other way, it would be 1, 0, 9, 8. That's the idea there. I'm using a -1 return value to sort of filter out. Remember how they said the zeros couldn't be in the middle, they had to occur only at the end. So if I get that descending pattern 1, 0, 9, 8, I'm just going to say, you know what, just, or here's where I return the -1. Just return -1 if it's not valid. And so that way I can check here if the target's valid. If it is, anything greater than 0 is assumed to be valid. I load it up. Remember the targets array from the or list from the interest calculator class is accessible here because I made it protected, so I can add my target rate to it. And I might have both an ascending and a descending. That's how I did this. If you want to see, I made this general get target that could cover both ascending and descending because, again, if I do it in two separate methods, there's so much that's in common between that process where it's the same idea where if there's a bug, you have to change something, you have to do it in multiple places, which is very bad. So here, the idea is that I give it the first value of the sequence, say 1. I tell it how many numbers there are. Let's say there's 4 if we're doing the 1, 2, 3, 4. And then I say ascending or descending. So I just grab that first value. This end of nums dilim had to do with the ASCII table. So I'm dealing with chars. And if you look at the ASCII chart, you'll see before 0 is the colon, and after 9 is the /. I may have those inverted, but those are the two that mark that you've run off the 0 through 9 characters. And so I need that. And then increment, I might be going up, 0, 1, 2, 3 if I'm ascending. If I'm going down, then I might be going 1, 0, 9, 8, 7. And that's sort of the idea there. Just generalized to handle either case. I note if a 0 is used, you basically go over the, I already have the first digit, so I just start at the value 1, the second character to grab, go over the length, grab the next value. So I'm taking this I-1 is that previous character. I'm adding the increment. It could be 1, it could be -1, depending on which way I'm going. And then I get the next value. So if the previous value is 1, I'm getting 2 here. And then I can check if I had run off the edge of the characters, right? If I encountered a / or a colon, it's like, ooh, I don't want to tack on a 1, 0 /8, that would be garbage. So it's to check to that. If I do run over, then I do hit this jump to val and I go back to 0 or back to 9 to get back in range. I note that I used a 0. This will be useful at the end where I can say, if there's no 0 used, I don't have to worry about it. But otherwise, I have to make sure that the 0 occurs at the end. And so you just basically keep tacking on the characters, pull the integer value from it to load up the target. If the target's valid, then I'll just simply return it. Otherwise, that -1 I told you about, that's a warning. And then that makes life a little bit easier up here. If you get a good target value, a valid one, add it. And that's how that works. So that's it for the sequential interest calc implementation. And that's pretty much the same for all of these. It was nice that I was able to factor out all of the work into the interest calculator class, right? Then I just say, hey, I just have these targets. I don't really care what they are. In any case, no matter what, I've got to check if there's full interest. I've got to check if there's almost interest. I don't care if they're palindromes. I don't care if they're 1s with 0s. I don't care if they spell obscene words. Just that's all I just want to do my job, right? So yeah, we'll go ahead and do another one that was sequential interest calculator. Let's help my OCD a little bit, huh? Okay, we'll go on to the next class. Public interest calculator. Okay, yeah, that looks good. We derived, right? Okay. We'll do the same digit one next. We'll say public class same digit calculator, I think is one, or I'm sorry, same digit interest calc. And again, that inherits from interest calculator. Make our scope. We're going to need that constructor, so I'll copy the class name. And it's going to take the name. We don't have any extra targets in this case. And same deal, just go to the base class, pass it the name so I can store it in that name field, right? And then we know we're going to override that add main target, protected override void add main target. And so what's the case with the same digit? Well, same thing. I'll just copy my implementation in there. Not much here. We had the input numbers stored, right? Again, you could have passed it. I convert it to a text. I basically grab the first digit, and then I just say repeat it the length of the text. So if it was 1331, I grab that 1 as the first character and just repeat it 4 times. Return 4 ones. Convert it into an integer value and add it to the targets. That was all I did for that. You could break this int parse out into a separate line. I didn't go crazy trying to check for, you know, if there were exceptions thrown or errors thrown with parsing values, but you could do that if you wanted to be more robust. But yeah, not much. Life was pretty simple here for the same digit interest calculator. So I'll move on to the palindrome. I should note that normally you'd be working in an IDE and you would break all these classes out into separate files. So this is, you know, it's not desirable just kind of running these all on in the same file. You wouldn't do that regularly. You'd create a new class, and the IDEs make it, they have buttons you can press and options to do that quickly and just make new files. That's a lot neater. Maybe in the future, if these challenges get large, I will implement them in the IDE and maybe move the answers back here. We'll see. So the next one, we'll do palindrome interest calc. It's going to inherit from interest calculator. And we know we need the constructor because we wanted to name it. Public string name. Invoke the constructor of the base class. Pass it name. We don't have any extra targets. And then we're going to override the add main target to do our magic. So I will put the implementation in here. Can talk about that. Okay. In the idea for the palindrome, remember it's the same forward and backwards. So I convert it to a string to make it easier to work with. I note the length. I grab the beginning of it, which is, I use this substring method to do that. The length over 2 is, you can think of it as sort of chopping the input in half. The end of the palindrome I'm building is just basically reversing the start, right? So that's pretty handy for doing that. And then finally, I'm going to build the palindrome. And I start with the first characters of it. I have this special case. Remember, modulo 2 not equal to 0 denotes an odd length. And I had hit a problem with 119. I was making a palindrome of 111. And it was not right because when you add 2, you get up to 121, which is a palindrome. So I had to sort of address that. I blew that the first time I had implemented this. And so if it's odd, I'm going to denote the middle digit, right? Then I'm going to account for this +2, right? The almost proximity. And I'm doing this basically to check if there's rollover when I add 2. And if there is, you know, if the added number middle digit doesn't equal the middle digit, I know I had a rollover. So I set it to that new value, the 2 in this case. You know, I had 119 here. I would make it 12 as I'm building it. And then I finally tack on the last character, which in this case was a 1. In the case of 119, the palindrome start is 1, you know, and then the end would have been 1 because I copied the start. I just reversed it. There's really nothing to do to reverse a 1 character pattern, but this works generally. And so, yeah, it goes to 1 2 1 instead of using 1 1 1, and that was causing problems. So I do that if necessary, and then finally I tack on the end of the palindrome, create it to convert it to an integer, and add it to the targets. And that's it for palindromes. Finally, we'll do the digits with 0. Since we've done a few of these, maybe I'll just copy the class text. We can just talk about that. You don't have to watch my awesome typing abilities. So digits with 0, right? Same idea. Colon, add the base class, which is saying this is a derived class. Now we have our constructor, same name. Pass it a name to set the name field in the base class. And then we have our specific behavior in the admin target. Again, we're converting to string. This was digit with zeros. I'm adding 2 again as necessary. In this case, I want to see if the first number rolls over. So imagine a number like 79998, you know? And then if you add 2, the number could be 8,000, right? It's not 7 anymore. I can't just grab the first digit, which would have been 7 in that case. So I'm either using the 7 or the 8, if you will, going with that example. There could be possible rollover. Then I mark the length, and it's basically saying to use the first digit, whichever one it was, and then just this enumerable repeat, which we've used, is fill it with zeros, and I do length -1 because we already have the first digit. And then the same idea, convert it to an actual integer, add it to our target list. And that should do it for the classes. So I'm trying to think if I missed anything else in here. Well, there's one way to find out, right? We know we can run tests. So let's see what kind of, I'm sure I missed something. We'll run the test. Okay, so let's go to line 8. Oh yeah, look at this. I called validate input when I'm supposed to pass it just a value, and I said int number like I was writing a new function. So yeah, that's bad stuff. Okay, error syntax, line 62. Let's go down to 62. What did I do? Private list, interscale. Syntax error, something expect. Oh yeah, I see it. Forgot that closing bracket there. So yeah, that was gibberish. Line 78. Invalid token. Yeah, I see it. I shouldn't have ended this with a colon, or I'm sorry, a semicolon, if I was going to make it a property. So definitely invalid. Thank you, compiler friend. What did I do now? Line 78. Expected. Oop, forgot the semicolon there. Wow, I'm on fire. Line 106. To input number. Wow, just getting really sloppy there. 106. It's like I'm grunting at the program. Get private. Semicolon after method on line 106. Yep, I did that previously too. No semicolon there for properties. Solution, CS line 12. Cannot declare instance. Sure. Yeah, so I didn't make my method static, which means I'd have to create an instance of kata, make a kata object to call it, but that's completely unnecessary for this kind of a method. It has nothing to do with member variables. It's just checking a number for a value. So we'll make that static. Line 6, not all code. Oh yeah, we didn't finish up the main is interesting method. So let's go ahead and finish that now that we've got all of our infrastructure in place. And it's easy, right? Interest. We can get this right from our catalog object that we created, right? Get interest number. And then, I wonder if I should add, that might be helpful. I had made a show contributions method which broke it down. I'll do that. It makes the output look nice. Return. I'll finally cast back to an int. I don't like the magic numbers, so I did it right at the very end. If I had made this, I would have just stayed using the enumeration. But we can go. Let's do that. I'll bring that show contributions in. Oh, that was a public method for the interest catalog class. Let's do it right after the get interest method. I'll put it right here. And so you'll see why I had that name and contribution field in the interest class. I put a tab in here to sort of break them out so you could see them between each test. And then with that, this helped me when I was doing this. I could say catalog show contributions. All right, I'll run my tests, see if there's any other errors I got in here. Name num does not exist on line 103. We'll go down to 103. Yeah, I don't think I had a num. It should be number. Interest does not contain a definition for has flags. I wonder if I forgot a system. No accessible extension method could be found. I notice I have a couple other using statements that I'll bring in. That'll probably save some other trouble. For has flags, what did I do there? Has flags. Oh, maybe it should have been have. There should be no has flags. It should be has flag. Yeah, not flags. Has flag. Sorry about that. Checking for one flag. Let's see. But yeah, you could see how we named each of these calculator classes. And it shows you what it rated. Awesome phrase chose almost. It returned almost interesting. And so that helps if you look at each number. Probably should have put in. We can have another line that will. Let's do that. This shows what the input is and what the result is. So you can kind of see that. Expected 0 was. Yeah, 11209 should be an almost, but it's saying we gave none, and it should be almost with the palindrome. So, see what I did there? to I'll add the I'll activate its log. Should have a log. Here we go. Here's the log statement. Let's take a look at what it's doing. Alright, it should have printed, oh, why didn't it print? Was that palindrome? Yeah, console write line, put number num text, start. It's weird that it didn't. I failed 4. Fail. Wonder why it's not printing my log statement there. Did I forget to make the class? Let's see, I got awesome phrase. Oh, jeez. Wow. Okay, I figured. Yeah, that's going to be a problem. So, if you want to think about what I did wrong here, I got a little ahead of myself in the copy paste there. So the problem is that I made all interest calculators, right? But the interest calculator was sufficient for awesome phrases, but we don't get any of the derived behavior. So it's not even calling those add main target methods of all the derived classes. You know, it's using the base one, which is doing nothing. So let's go ahead and make the appropriate type. This one should be sequential interest calc. The same digits one is same digit interest calc. Probably palindrome interest calc. And then this one would be digit with zeros interest calc. Let's test this, hopefully. At least now the methods will be called. There we go. Yeah, that was bad copy paste. That was confusing there. Sorry about that. We'll go ahead and run the attempt. Okay, good. We're clear for submission. So I'll probably remove the comment lines there. One other thing I'd say, if you want to clean up the magic number here, we made a constant for that, the almost proximity. That you could do that. That's what I would do. Any other comments? I'm going to remove the comment from the palindrome. And then, yeah, that's good. And, you know, I did kind of these add main targets, the specific behavior for palindromes and stuff. I did those quick. I'm sure there are better ways of generating the targets for this. I didn't spend a lot of time on that. So if you want to optimize that too, that could be a good exercise, or you could do it however you want. But it's kind of nice in breaking everything out this way, right? In that, you know, if you want to change an implementation, you don't even really have to think about it that much. You just kind of put the implementation that comes to you. That's what I did. And then if I were testing performance, I could see, oh man, this implementation sucks, and I can go right to the one that I know. It's already, all the code's organized, so I can go right here. If I had made this into one giant method and I'm trying to scroll through and figure out which one is doing the digit with zeros versus same digit, you know, it's a nightmare, and you're trying to change your implementations, and it is such a mess. So Again, another benefit of sort of breaking your code out into other classes, keeping it very small, definitely worth the trouble. So I hope this was a helpful introduction to inheritance for you as well. I know we didn't get to touch on all the ideas in this video, but it's running significantly longer than normal, so I'm going to send mine off here. And you know, you can just leave me a question, I'll get to it. We'll submit it. Grab that well-earned kata. So yeah, we got it. Wow, went over 300. Powerful you are. You ranked up to 5 Caillou and C#. Cool. Yeah. So lately, you've probably noticed that the challenges are picking up in difficulty, or at least the amount of work you're doing. So I've been kind of just jumping to the next kata thing. I was getting a little annoyed by going out to the main menu, always picking the easiest. It was giving, I think I was getting new challenges come in that were too much fluff, you know, how to do an if-else statement, and I just don't want people to get tired of this series. I don't know where everyone's at, you know, if they think it's moving too slow, too fast. So I just try and use my judgment. Feel free to drop those comments and say, hey, slow down, buddy, or pick it up, buddy. So yeah, you can look through other people's implementations here. I'm not going to spend a lot of time doing that. But yeah, I'm sure there's something, very much something to be learned there. Maybe I'll look at them over. But yeah, any questions, hit me up. Thanks for watching. If you got cool implementations like are no doubt to be found in here, definitely share them. And I will see you in the next video. Thanks for watching.